Hello everyone. Today we'll learn about valency and Lewis dot structure. Here valency means combining capacity of an element. In this we should know about valence electrons. Valence electrons means electrons that are present in its outermost shell. What is meant by outermost shell? Here let's take one example, a boron. Boron is an element with its atomic number 5. So, if I'll write a configuration, I'll get 1s2, 2s2, 2p1. Diagrammatically, 1s2, here dots represents electrons. According to Borbary rule, first shell, that means K shell, can accommodate only 2 electrons. That's why I wrote only 2. And we'll go to the next shell, that is second shell called as L. There, according to Borbary or a 2n square formula, we can accommodate till 8 electrons. So, as its boron is 5, its atomic number, so 2s2, 2p1, remaining out of 2 we got and only 3 electrons are left. That I have written in a second shell, that is L shell. 1s2, 2s2, 2p1. According to this configuration, outermost shell for this boron is the last shell, that is 2. The second shell is called as its outermost shell of boron. How many electrons are present in the outermost shell? Just you count. This number indicates outermost electrons. That means 2 plus 1. The electrons that are present in the outermost shell are called as outermost or valence electrons, and the shell is called as outermost shell. Number of electrons in the outermost shell of boron are 3. That's why I have written here valence electrons is equal to 3. And then if I want to find out the valency of boron, the formula is valency is equal to its valence electrons if valence electrons are less than 4. Now you count for boron, valence electrons are 3. That means this number is less than 4. Then its valency is equal to its valence electrons. Again I am repeating, valency is combining capacity. Valence electrons are electrons that are present in outermost shell. Valency is equal to its valence electrons if valence electrons are less than 4. That is the formula. So, number of valence electrons for boron is 3. It is less than 4. That's why valency of boron is 3. Valency of boron is equal to 3. That means boron can combine with 3 other elements. Let's take one molecule formed with boron, that is boron trifluoride. Boron trifluoride is a molecule where boron is B for boron is combining with 3 fluorine atoms. These 3, see here the valency of boron is 3. In the name itself it is there. Combining capacity of boron is 3. That means valency is 3. So B of 3 is equal to B with the 3 fluorine atoms. Now if valence electrons are more than 4, what is the formula? Valency is equal to 8 minus number of valence electrons. Valency is equal to 8 minus number of valence electrons if valence electrons of any element is greater than 4. Take one example, nitrogen. Nitrogen is equal to its atomic number 7. Now let's write electronic configuration. 1s2, 2s2, 2p, 3. What is its outermost shell? This is called as its outermost shell. How many electrons are present in its outermost shell? Count. 2 plus 3. 2 plus 3, that is equal to 5 are its valence electrons for nitrogen. When valence electrons are greater than 4, then you have to apply the formula 8 minus number of valence electrons to find its valency. Now valency of nitrogen is equal to 8 minus its valence electrons. How many valence electrons we got? 3 plus 2, 5. 8 minus 5 is equal to 3. So valency of nitrogen is equal to 3. Now that means it can combine with 3 other elements to form its molecule. That is called as valency. Got it? Now representing of this valence electrons around the nitrogen or around any element are called as Lewis dot structures. Here representing of an element with its valence electrons in the form of dots around it is called as Lewis dot structure. Lewis dot structure. Let's take an example to write Lewis dot structure. Here I am taking nitrogen. First of all, you write symbol of that element. I am taking here nitrogen, so I took N. Now count the number of valence electrons. Already we counted here valence electrons of nitrogen are totally 5. So represent that 5 electrons in the form of dots around this symbol. Now you count 1, 2, 3, 4, 5. You can represent this Lewis dot structure in the form of dots around this particular element, or you can also represent like this. 1, 2, 3, 4, 5. You can use either dots or into marks to represent this Lewis dot structure around this particular elements. Now with this I'll end my topic. Thank you.